Hello, everybody. Mr. Wyatt here again, and we are reviewing one more day today, sections 6 through 10 of topic 4, and then tomorrow we're going to take our topic 4 assessment. So anyway, I'm going to see if I can get through all of these problems in one video. If I can't, then I'll finish with a second video. So let's see how it goes. All right, number 1, the age of the house, A, is greater than 3 years. Here's the key right here, is greater than. So could it equal 3 years? Could the house be 3 years old? No, it has to be greater than 3 years. So we're not going to have an equal to in this, so it's not going to be this one here with the equal in it. It has to be just the greater than one. The age of the house has to be greater than 3. If it helps you out, the alligator always eats the larger value, okay? And so the alligator is going to eat a number that's larger than 3 because the age of the house is more than 3 years. No, excuse me. Number 2, the number of people, N, living in a house is at most 5. So question, can 5 people live in the house? Yes, but that's the most that can live in the house. It can be at most 5 people. Now, could it be 6 people? No, that'd be too many. It can be at most 5. Can it be 4 people? Yes, it can be fewer than 5 people. It just can't be more than 4 or more than 5 people. Okay, so the number of people and living in the house is at most 5. So it could be 5 or it could be anything less than 5. So it has to be less than or equal to 5. We choose that option because you can have 5 people in the house, but that's the most you can have. At most, it's 5 people. You can have fewer than that. So n is less than or equal to 5. All right, number 3, up to 15 people, P, visited Mary today. That's a lot like number 2, isn't it? No more than and up to kind of mean the same thing. So you could have 15 people visiting Mary today, but no more than that. So it has to include 15. We need the equal in there. So it has to be one of these two, not these two, because it could equal 15, but it could be a number that's less than 15 as well. So the number of people that visited Mary has to be fewer than 15 people or exactly 15 people, less than or equal to 15. Number 4, the number of guests, G, coming for dinner is not 8. Could it be more than 8? Yes. Could it be less than 8? Yes. Well, then all we know is it's not 8. It's not 8. So that would be this one right here, where we have the not equal to symbol. It could be anything else. It could be more than 8. It could be less than 8, but it's not equal to 8. Number 5, the distance of the race, D, is at least 6 miles. So it might be exactly 6 miles, right? If it's at least 6 miles, it could be 6 miles. But if it's at least 6 miles, it could be more than 6 miles also. That's an up arrow to show more than. So it has to be greater than or equal to 6, the distance, which is this one right here. The distance is greater than or equal to 6. All right, now number 6, what inequality does this graph represent? When you look at number 6 and number 7, they are similar in that we have a number line graph, a number line showing a graph with an arrow. What's different is this one has an open circle. This one over here has a closed circle. So when do we use each of these? You know, if the circle is open, that indicates the number right there is not included in your solution set. But if it's a closed circle, yes, that number, in this case a 3, is included in the solution set. So when I look at this number line, my arrow is pointing to the left on the number line, which is all the numbers that are less than 10. But 10 is not included. X here is less than 10. Okay, it's not less than or equal to. If we wanted equal to involved here, we would fill in that circle to make it equal to it. This one, though, with the closed circle tells me it's equal to 3, so I know it can't be greater or less because equal has to be part of it. It's equal to 3 and everything greater than 3. So x is greater than or equal to 3. So that's an open circle, means you cannot include that number in your solution set. Closed circle means yes, you include that number in your solution set. Which graph correctly represents y is greater than 5? When we were talking about open and closed circles a little bit ago, when would we have the equal to in our symbol? Well, whenever we have a closed circle. This inequality does not have the equal in it. It's just greater than 5. So I know it can't be a closed circle. It won't be A, it won't be C, because those both have closed circles. All right, so if y is greater than 5, both of these have a circle at 5, but the one that is showing values greater than 5 is B. Okay, D is showing the values that are less than 5. So it's definitely B. Y is greater than 5. We need an open circle because 5 is not included in the solution set. There's no equal. And then everything to the right are the greater than values. Okay. Number 9, which graph correctly represents x is less than or equal to 7? This time it does have the equal to as part of the symbol. So we need a closed circle. So I know it's not A, that has an open circle. I know it's not D, that has an open circle. It has to be B or C. So which one is showing the values that are less than 7? B, the arrow is going to the left, which is where all the values that are less than 7 exist on the number line. C, it can't be C because those are values that are greater than 7. So it's B. We have the closed circle and arrow to the left for x is less than or equal to 7. B is our answer choice. Boy, we're moving right along here, aren't we? Number 10, fill in the missing values in this table. We have x 0, 2, 10, 16, 20. So we're not going in order here. We're skipping some numbers. And our y values are 0, 1, 5, blank and blank. So whenever we're trying to fill in missing values in a table, we're trying to figure out how do you get from x to y? How are you getting from your input to your output? And you want to be doing the same thing every time. How do we get from 0 to 0? From 2 to 1? From 10 to 5? You know what? It looks like I might be dividing by 2 every time. Well, 0 divided by 2 does equal 0. In fact, 0 divided by anything will be 0. As long as you don't try dividing by 0, you can't do that. But otherwise, you can divide by anything and it'll equal itself. 2 divided by 2 does equal 1. 10 divided by 2 does equal 5. In fact, you could say these values here appear to be half of these values here. So what is 16 divided by 2? It's 8. And what is 20 divided by 2? It's 10. So 8 and 10 are my missing values in this table. Okay. Number 11, which equation represents the pattern in the table shown in number 10? Well, our equation, y has to equal x divided by 2, doesn't it? And that's this one right here, y equals x divided by 2. Just so you know, y equals x divided by 2 is the same thing as y equals 1/2 times x. Because dividing by 2 over 1 is the same as multiplying by its reciprocal, 1 over 2. Okay, so you could say it either way, but y equals x divided by 2 is one of our choices here for number 11. All right, number 12, use the equation y equals 6x plus 1 to complete the table. So when I have a 1 here, I'm going to substitute that in for x. We have 6 times 1 plus 1. Okay? When x is 2, we're going to take 6 times 2 plus 1. When x is 3, we're going to have 6 times 3 plus 1. When x is 4, we have 6 times 4 plus 1. It's like we have a pattern. When x is 5, we have 6 times 5 plus 1. Well, what are these all going to equal? We need to evaluate each of these expressions now. 6 times 1 is 6. 6 plus 1 is 7. 6 times 2 is 12. 12 plus 1 is 13. 6 times 3 is 18. 18 plus 1 is 19. 6 times 4 is 24. 24 plus 1 is 25. 6 times 5 is 30. 30 plus 1 is 31. So my values here would be 7, 13, 19, 25, 31. Do you see that here anywhere? Yeah. 7, 13, 19, 25, 31. Oh my goodness, nothing to it. Number 13, use the equation y equals 2x minus 4 to complete this table. So here I have 2 times 2 minus 4. Here I have 2 times 3 minus 4. See, I just keep changing what I'm substituting in for x. Here I have 2 times 4 minus 4. What's important to remember is 2x doesn't mean like 22, 23, 24. It means 2 times x. 2 times 2, 2 times 3, 2 times 4, and then minus 4. So 2 times 2 is 4. 4 minus 4 is 0. 2 times 3 is 6. 6 minus 4 is 2. 2 times 4 is 8. 8 minus 4 is 4. So my values for y are 0, 2, and 4. That's this one right here. All right, number 14. Which graph correctly represents the equation y equals 2x minus 4? Do not try solving this problem unless you first make a table, an xy table. Once you do that, it'll be really easy to spot which graph is correct. So what you can do is, since my graphs for my x values go from 0 to 5, let's just try a 0, a 1, a 2, and then we'll go from there. Okay? So if x is 0, 2 times 0 is 0. 0 minus 4 is negative 4. We haven't really worked much with the negatives. If x is 1, 2 times 1 is 2. 2 minus 4 is negative 2. When x is 2, 2 times 2 is 4. 4 minus 4 is 0. I don't like these negatives here. Our graphs are all showing positives. So let's try some x values that are bigger, like 3 and 4, and see what happens. When x is 3, 2 times 3 is 6. 6 minus 4 is 2. When x is 4, 2 times 4 is 8. 8 minus 4 is 4. I'm going to focus on these right here. 2, 0, 3, 2, 4, 4. 2, 0 is right here. That's not on that line. 2, 0 is right here. That's good. 3, 2 would be here. Uh-oh, this is 3, 1 here. 2, 0, that's good. 3, 2, 3, 2, yep. 4, 4, 4, 4, yup. C is our answer. D has 0, 0. That's not one of our options here. So it is definitely C. But again, to do this, I really need to make a table first. All right, one more. I have to be fast. Which equation correctly represents this graph here? Well, I have a point here at 1, 2. I have a point here at 2, 4. I have a point here at 3, 6. I have a point here at, well, that's the last point, 3, 6. Remember, ordered pairs are always x followed by y. So in my table, I have 1, 2, 2, 4, 3, 6, and so on. How are we getting from x to y? It looks like I'm multiplying by 2 every time, doesn't it? 3 times 2 is 6, 2 times 2 is 4, 1 times 2 is 2. So that means I have y equals 2 times x. right here. We did it. Good luck on the test tomorrow.